Hello guys, I'm Sandip and I'm a physics faculty at askIITians. So if you do remember in the previous session, we have or in the chapter of energy, we already completed two sessions of the on the energy, and we studied the different types of sources of the energy, right? So as you already know that to function for any machine or for us human being also, we need energy, right? So tell me how we are getting the energy. Yes, we are getting the energy by food source. Okay. What about the machines? We also seen in the last two sessions that important energy which we do require nowadays is electrical energy, and the other one is fuel energy, right, for our cars and bikes. So what are the others energy we actually do require? Yes, anybody? Yes, we do require the we can say gas cylinder for cooking in the kitchen, right? That is also the important thing. So why we cannot use just the electric energy to cook? Obviously, yes, we do. We can. We do have the electrical inductions also, right? But that will take obviously a lot of energy, a lot of electricity. So normally we do not use that, right? So gas cylinder actually is a cost effective, we can say, way for the cooking, because obviously it will need a lot of time to generate that heat, and electricity can generate it, but it will be a lot of power we need for that, and your light bill will be very high if you use the electric inductions, right? But yes, for low purpose, small purposes, we can say, let's say uh, to make a coffee or to heat the water, right? We use the electrical appliances also, right? Yes, so these are the three actually energy sources, energies we actually do need. One is electrical energy, then gas energy, we can say, for cylinders, and also fuels for our cars and bikes, obviously. Okay. So also we have seen that there are different sources. Some sources are renewable sources, and some are the non-renewable sources, right? Okay. So consider, tell me, one, we have already studied this, why we are not using the solar energy to drive the car or bike. Yes, anybody? Why we cannot just use the solar energy? Why nowadays we even know that petrol prices are getting very high and high? So solar energy is anyway free. Why we cannot use the solar energy to drive the bike, right? Because obviously, so for solar energy, there is a need of solar panels. Where you are going to put the solar panel on the bike, right? That is the one thing. Then why we cannot use for the car? Anyway, yes, we can use it car for the car, but cost will be very high. Nowadays, cars are not that difficult to thing to buy, right? Even you can get the uh, new cars, right? New branded cars up to 5 lakhs or 6 lakhs something, right? But if you use the solar panels on that, then that cars will be very costly, right? So that's why we do not use. Also, one more thing which is very important, that solar energy is not consistent. We know, we have also seen that in the previous session, that it is not consistent. So if the clouds cover the sun, our car will stop in the middle of the road, right? So we have to wait for the sun, or in the night we have to wait to sunrise, right? That is not practical. That is not feasible. Therefore, we cannot directly use the solar energy nowadays, right? Then we also have seen fossil sources. Fossil sources, which are the major chunk of the energy now. They are producing a lot of energy, right? So those are the major sources now. Which are the fossil sources? You do remember, you see in the oil reservoirs are there, oil wells are there. Then natural gas. Both of these oils and natural gas, we have to extract from the earth, right? That we know. But yes, they are very powerful sources and consistent sources, we can say. But unfortunately, they are not renewable sources. They are going to end sometime, right? That part we already know. And also one more very big disadvantage is absolutely not good is they do the pollutions. Pollution is not good because we do use the car and bikes, but yes, nowadays there's a lot of pollutions, right? Even if you look at the sky at the night, sometimes it is not uh, we are not able to see the lot of stars, right? Because of those pollutions. So any obviously we don't want that. Therefore, nowadays humans are trying to find a more fresh source or a eco-friendly source, we can say, right? Which do not pollute the air. So yes, we also have studied a lot of eco-friendly sources there, right? In the previous session, was for that, right? Eco-friendly or our non-conventional sources which do not do any pollution, right? Which are the sources we have studied? So initially we talked about the water hydro plants, right? There are big plants, but and yes, what we use there, potential energy of the water. Why the water has the potential energy? Because it is stored up at the height. But again, the problem is we have to construct the big dams, big power plants, right? That is very that is difficult for the cost wise. We can say it is not very good. Then we also seen about the that wind turbines, right? Better than we can say hydro plants, right? Because we don't have to store the wind. But again, the problem occurs where we should place the wind turbines because we cannot put them in cities. We need to find some places where there will be a lot of wind, right? There only we can put the turbines. Then we also talked about a biomass, right? So again, the biomass actually, biogas plant actually used in the villages most of the times to create the methane gas, right? Which could be used for the cooking purposes, right? Then one more thing we have seen is the tidal, tidal waves, tidal energy, right? The tidal energy means we can put the turbines inside the water, right? So the turbine is going to rotate in the water and we are going to get the energy. And anything like normally what we have seen that every source actually we are using that to move the turbine, rotate the turbine. And what is the job of turbine? To create the electrical energy. So to rotate that coil, that is the case. Okay. So all the energies we have used for those part, right? Also, we have seen that geothermal energy. What is geothermal energy? Thermal means heat, and we have to extract that heat from what? Obviously, again from the earth. So again, that's not an easy task. We have to build the towers, big towers like this. Here you can see on the screen. We have to build the big towers like this, right? And it is we have to do some construction in the ground also, right? We have to go towards the core, not exactly the core, but the magma. We have said that part, right? Towards the magma of our earth. Magma is the part which has a lot of heat. So we have to create one water reservoir there, and uh, the earth's magma is used to heat that water reservoir, right? Which converted into the steam. And then we got, yes, that steam obviously rotates the turbines again. And we know that's the job of everybody, every source that to rotate the turbine, because by rotating we get the alternating current, and that alternating current is transferred to every household or manufacturing company, and we use that in electrical energy form. We also seen that part that transformers are there, right? So transformers actually change the voltages of the current or electricity or the light, we can say, right? Okay. So these are the sources of energy, which are some are non-renewable, some are renewable, and we also know what are the advantages and disadvantages of those now, right? One energy we are going to see today, right? We just call it nuclear energy. Nuclear energy. Again, they also have this big towers like this, right? So how this nuclear energy? Obviously, we say the nuclear energy. Can I say it is related to some atoms and whatever is there inside the atom? Obviously, right? Okay, so how to get the energy from that? Now, everything is made up of atom, and every atom gives that much of energy. That is also we are going to see today. Okay, good. So let's see. So this is the nuclear energy. This is the last topic of our session, and I think you have already covered all the chapters of the physics. So maybe the last session of the physics we can say, right? So this whole chapter is a quite a theory part we can say. So not that difficult. You just have to remember the concepts of all this, and you are good to go, right? Good. So nuclear plants actually do look like this. There are very big towers. You can see some steam is coming out of it, right? So how does nuclear energy work? How we can actually get the nuclear energy? We can see those. We are going to see those things, right? So first of all, let's see. Yeah, you can see the total energy distribution in which we have studied about the renewable. Renewable only is 8%. Raise small fraction is there, right? Renewable energy which we are actually using nowadays, right? So in renewable, we studied the solar energy. You can see only 1% of the total energy, whatever we are using, whatever humans are using, right? Only 1% of that energy is the solar energy, right? So obviously we have to increase that percentage, right? Because solar energy is the purest form of the energy, and we seen in the previous session that sun is our ultimate source of the energy, right? So yes, obviously scientists are doing research on how to make it cost effective or consistent, so we can use that energy. Okay, so that's the thing. Then we have, let's say, geothermal energy. You can see we are only using geothermal energy. Yes, obviously geothermal energy, it needs a lot of a bigger plant. Construction cost is very high, right? We have to put the reservoir inside the earth. It's not that easy. Then biomass, we can say 6% of the energy we use, not a total 6%, we can say 6% of this renewable. So only this green part 6%. So again, solar energy, also green parts 1% we are using them. Okay, like this. Then wind turbines are there. We have seen those, but those are also, so all these energies you can consider, right? All total of this is only 8% we are using, right? So total whatever 100% energy we are collecting from different sources, only 8% are from the renewable sources. Yes, so obviously we have to focus more on how we can actually get more of this renewable energy, because it is non-pollution energy. It is our eco-friendly energy, we can say, right? Okay. Then in coal, you can see, right? Coal, we use a lot of energy from the coal, 21%. But again, the problem is it is not renewable. Coal mines are, obviously there is limit how much coal we can use. Once that coal mines got finished, then we don't have any other option, right? Similarly, you can talk about the petroleum. So 37% of our energy is now comes from the petroleum. Petroleum means oil, petrol, diesel, right? Not only those things, but other oils also we can use those oils in the cooking in the kitchen, right? So those are oils are also we can say comes from this oil things, right? Then natural gas. So we already have seen this natural gas, coal, petroleum. These are our fossil fuel, which is called as fossil fuel. You can see almost how much? 25 plus 21 is how much? Let's say 46. 46 plus 37. So 46 plus 37 is almost 83, right? So total 83% of the energy we are using now, it's because of the fossil fuel, right? So that's actually the big reason to worry. We have to include a lot of renewable energy, because we know that fossil fuels are not good for environment. They cause a lot of pollution there. which we do not want, obviously. Okay. Then yes. Then the last energy which we are going to study today is the nuclear energy, which has a 9% share, right? Okay. So let's see now how this nuclear energy we get this nuclear energy. So first of all, there are two types of the nuclear energies. How we can get actually the nuclear energies or nuclear, let's say nuclear reactions. So first is fission and second is called as fusion, right? So here obviously you can see that I can see here the bigger molecule something. Yes. So this is the molecule, let's say original parent molecule, and it is splitting into, let's say, two different molecules. It is called as fission, right? And if the smaller molecules comes together and create the bigger molecule, we are going to call it as fusion, right? So these are the two types of the nuclear reactions we can say. So if one bigger element breaks into two parts, it is called as fission, nuclear fission. And if the two or more lighter elements, small elements, comes together to create the bigger element, then we are going to call it as fusion. In both the cases, actually, we do get the energy there, right? Okay. So example for fission, you can obviously consider the nuclear bomb, right? Where the nuclear bombs are dropped in Japan, right? In Hiroshima and Nagasaki. So already we know how much destruction it can do, right? So obviously if it is doing some distraction, means it can generate that much of energy, right? So if it can generate that much of energy, can we use that energy for the useful purpose? Yes, we can in the nuclear reactors. How that we are going to see, obviously, right? Then in fusion, the best example for fusion is our sun, right? So in the core of the sun, we know the sun is very hot, right? Uh, you can even see in the diagram, right? So it look like it is just hitting. There is a lot of temperature is there, right? So how we are actually getting that temperature? How the sun is getting that temperature, that heat? It is because the fusion is there in the core of the sun, right? So hydrogen must be there, and the hydrogen is taking part in that fusion, right? Obviously, after very long time, when that again obviously the fuel in the core of the sun will end, then sun will die, we can say. But again, that is not our worry, because it is a lot of it will take a lot of years for sun to die, right? So this is fusion and fusion. Now let's see. First of all, we already know the atomic structures. So this is the carbon atom. You must have studied this in the chemistry, right? What are there in there is a nucleus. We know that part. In nucleus, it is a positively charged nucleus. It also has protons as well as neutrons. So protons has what? No charge, right? Sorry, protons has positive charge. We know that part. And neutrons are neutral. What about these electrons? Electrons have negative charge. Why we are studying this again? We already know this thing, right? But obviously nuclear energy means it is related to nucleus or atom. So let's see first the basic of the atom. So hopefully you all know, are very familiar with this positive, negative, and we also know that atom as a whole is a neutral. Why? So if there are, for this carbon we can say, if there are 6 protons are here. How many electrons are there? 1, 2, 3, 4, 5, 6. So 6 positive charges, 6 negative charges. And we also know the charge. What is the charge on proton or electron? Charge is 1.6 into 10 raised to minus 19. Let's say positive for proton, and for electron it is 1.6 into 10 raised to minus 19. So same charge is there. So if the 6 protons are there, 6 electrons are there, and neutrons anyway don't have any charge. So what I can say, atom as a whole is a neutral. Okay. So now let's see the important thing we need for this nuclear process, the isotopes. Now, what is isotopes? Here you can see nuclei from the same element with the different number of neutrons. Right? Again, nuclei from the same element means if you take the carbon, right, then it will have the same elements of the number of neutrons, we can say, right? Same element, carbon is the same element. We are taking the three different elements of the carbon, but number of neutrons are different, right? So let's talk about the nucleus only now. Forget about the electrons which are revolving in the circle, right? So what I'm saying is that yes, nucleus, we have seen in the previous case that in the nucleus there are 6 protons and 6 neutrons are there, right? So 6 protons, 6 neutrons is the nucleus. Obviously positive charge will be there, right? Now consider if there are 6 protons and 7 neutrons, right? Yes, those are available, right? Neutrons are there. So these two things are called as isotopes. Again, here you can see 6 protons and 8 neutrons, right? So this atomic mass becomes 14, here 13, here original is 12. So atomic mass is increasing because number of neutrons are increasing. So if the number of neutrons are increasing, what is going to happen? You can see this is the basic carbon. It is a lightweight, we can say. Then one neutron is added, one more neutron it has, it becomes heavier. One more neutron is there, now it becomes unstable. And now this unstable isotope is going to give us some energy or that nuclear reactions. Okay, here you can see most of the isotopes are stable, but some can spontaneously break apart. So what will happen if this is unstable, right? These are called as isotopes, right? We said that this is the isotopes which have the different number of neutrons, obviously. So if the isotope is unstable, this spontaneously breaks apart. So what is going to happen? Obviously, if they are breaking apart, they will give you the smaller particles, which will have, let's say, 1 proton, 1 neutron, and like that. Okay? And they emit the energy. This energy we are going to convert into our useful form. This is called as radiation. So what I can say that yes, we are going to need. We can collect the energy from these unbalanced isotopes. Okay, good. So let's see. So as I told you, there is nuclear fusion is one part and nuclear fission is one part. Okay, so uranium. Always remember uranium. Uranium. It looks something like this. Right. So this is the uranium. Uranium 235 has an extremely large nucleus, right? That can be split with if it is hit with the high-speed neutron, right? So obviously uranium 235, when we say carbon has 6 protons and 6 neutrons, so therefore its atomic mass becomes 12. You can imagine uranium is 235 number means how many protons and how many neutrons are there. Very large nucleus, we can say. A lot of neutrons and a lot of protons are there. So it is actually the radioactive element, right? So it is giving some radiations, and we can split that nucleus. How to split that nucleus? Bombard the high speed neutron onto that nucleus, right? And what will happen? That nucleus will burst out. Okay, so obviously in the previous slide we have seen that unstable isotope is there, it is going to break apart and emit a lot of energy. Same thing is going to happen here. When we bombard the neutron on that uranium, it is going to break, right? And release a lot of energy. Here you can see, here uranium nucleus is there. What we have to do? Bombard it with neutron, right? Here, okay. So this process is actually used in nuclear bombs, right? nuclear bombs which were dropped on Hiroshima and Nagasaki. We know that part. Right? That created a lot of energy. How it created a lot of energy? Because there is a chain reaction, right? So here you can see in the nuclear bomb, large amount of uranium is clustered together. So this uranium you can see, right? This uranium is clustered there in the nuclear bomb, right? And so that when the fission is initiated in one of the atoms, obviously, when we say that this is only the one atom, right? This is only the one atom, and in this uranium, you can imagine how many atoms are there. Lot of atoms are there, obviously, right? So what happens when you bombard this neutron on, let's say, one of the atom? What is going to happen? It splits and release more neutrons. So normally, when you bombard one neutron, we get the two small particles, right? And three more neutrons. This is first, second, and third. So what happens in nuclear bomb? They actually bombard it with the neutron. Just one neutron you need. After that, this uranium get converted into smaller particles and three more neutrons. This is only for the one atom, and as I said, there will be lot of atoms will be in this part, and this whole part is kept in that nuclear bomb. What is going to happen? If this neutron is going to bombard another nucleus of the another atom of the uranium, we can say, again it will create the smaller particles and three more neutrons. This three more neutrons are going to again bombard, right? So this chain reaction gets started, and every time when this splits, we get a lot of energy, right? And now you can assume that in the nuclear bomb, how that lot of energy is converted, because every nucleus when split gives a big amount of energy, right? And this process is going to stop? No, as long as whole thing is burst out, this process will not stop, right? Therefore, this is called as chain reaction. Remember, very important that fission is a chain reaction. Okay, so this is how we can actually get the energy. Now let's see how we can use this nuclear reactors now. So this is the nuclear power plant, right? Again, the output, or we can say final process, is same. It is not going to change. What we have to do? Ultimately, we have to rotate the turbine. That is our main pattern, right? In every power plant we have seen, that is the main thing, that we have to rotate the turbine. And turbine once rotate, that that gets to your AC generator case, right? You must have studied that in electrostatics, right? Okay, so what we are doing in the nuclear reactors? Obviously, we are going to start that reaction. We have to bombard that neutron. But obviously, it is not like a nuclear bomb. We are not dropping the nuclear bomb on the nuclear reactors. It is a controlled reaction, we can say, right? So here you can see controlled rod also there is, right? So actually, there is obviously some process to stop this chain reaction, right? As we seen that in nuclear bomb, that chain reaction will not stop. But yes, there is a controlling method also is there, right? We can actually stop that chain reactions too, right? Okay, so let's see the process. So first, energy released by the nuclear reaction hits the water in the pressurized first circuit to a very high temperature. So what is the job of nuclear energy? To create a lot of heat. That we already know from the nuclear bomb. Nuclear bomb do that. Same thing we are going to do, but in this case, controlled. We have to control it, obviously. Okay. So that energy is released, and now this energy, right, we can use for this water reservoir. So here again we have to use some water reservoir, right? So what will happen for this water? If the again heat is generated, what is the job of heat? To convert the water into steam. Simple. Okay, then whatever steam is getting generated here, take it to this part, right? Let's say this is from the first part where we collected the energy, which had the fuel rod and as well as control rod. So there, heat is generated from this pipe. We can actually boil that water. Water will get again into steam, converted into steam, and that steam in the third part, steam you can see, steam is directed against the turbine, setting it in motion. So to rotate the motion, simple, and turbine set the generator in motion, and electricity generated, right? So electric current, then you can again there will be towers and send energy. Towers are something like this, no? Something like this, towers. So those towers will again generate the, give the energy to our, we can transfer that. That's not difficult, right? Then whatever steam is there, obviously once they rotated the turbine, it will again go there. Here we can say cooling circuit will be somewhere, cooling circuit is there. So third circuit cools the steam from the turbine, and the waste heat is released from cooling tower in the form of steam, right? So obviously heat is also the going there with the steam. Now that heat we can let it pass through this cooling tower. So very big towers in the start, let's see, we are seeing this. Yes, these are the very big towers are there, right? So all the heat which is waste, it is given out in the form of steam, we can say, right, from this cooling tower. And obviously again it will also cool, and it again becomes water. Water again we can take to the original reservoir, like this. Okay, so this is how the nuclear reactors work. Then, so this is a nuclear uh, fission we have seen, in which chain reaction is there, and we have to bombard neutron on the uranium nucleus, and it is going to generate a lot of energy every time the atom splits. One nucleus split, lot of energy it will generate, right? Now let's talk about the nuclear fusion. Right? In nuclear fission, we have seen there was a big element, uranium 235, and we have splitted it into small particles. Now, fusion means combine the particles. So fission means break the particle, split the particle, bigger particle we can say, and in fusion we are going to combine the particle. Right here you can see deuterium. Deuterium means hydrogens isotope, we can say, right? Helium, tritium, right? So actually deuterium and tritium, all these, those are the hydrogen isotope, as I said, in our sun's core, right? Sun is doing the nuclear fusion process. All the hydrogen is there. So these isotopes must be there, deuterium, tritium. And when this deuterium and tritium comes together, fusion happens. And we are going to, now these are the smaller elements. Hydrogen is the smallest, right? We know that. So because of that, we get the bigger element. This have one proton, you can see positive, positive. We got the two positive means 2 plus, we can say, that is helium. You must have studied this in the chemistry, right? And it also eject one neutron, and again lot of energy is given. Okay, so this is how the nuclear fusion takes place, and we get the energy. Yes, so energy is the product of both the processes, whether it is a nuclear fusion or nuclear fission. Okay, the content, we can say power plant, something looks something like this, right? So deuterium source is there, right? Then yes, they have used, here you can see deuterium is coming from this side. There is plasma. Plasma means where the very high temperature is generated, right? Like a sun, right? Sun has a high temperature. Here also high temperature is generated. Then what you are going to get from this? Here you can say lithium is also used there, like tritium, right? So here you can see deuterium is going, and neutron is going out, and helium is given out here, like that. So we are getting the that helium extra. We don't need the helium, right? We need this energy. This energy is important for us. So we can say this is just like a waste, or we can use those as a byproduct somewhere, right? Okay, so this is how we can get deuterium. You can see whatever deuterium is there left, which will again go inside like this, right? And we can also use the tritium also there, right? So these are the fuels. They have called it as a fuel cells. Lithium is also used there, right? Normally lithium is used for as a blanket, you can say, so that those whatever deuterium, helium are there, they will not get there, get out of that part, right? So this is act like a insulator type something we can say. It is a blanket, right? It will not let that deuterium, helium, etc. out of the power plant, right? Okay. Then obviously what we create from here, energy in the form of, we can say, heat. Once we got the heat, what we have to do, just uh, put the water reservoir in between, get the steam, and steam, what the steam will do, steam will again rotate the turbine. The process is again same. Turbines process is same for everybody, right? So that's a very easy process to understand. Okay, so this is the nuclear fission and nuclear fusion, two things are there. Okay, now once it is done, nuclear fusion is done, then we can see that even in this case, these are the byproducts, or in this case we can call this as waste. Let's call this as nuclear waste. And as they are radioactive means very dangerous, we know that part. So we cannot just normally, other manufacturing, in case of let's say hydro plant, water is the, we rotate the turbine by water and water goes again. So water is not harmful. We require the water anyway. Wind is not harmful, right? But this nuclear waste is very, very harmful. So the main concern of this nuclear reactions or nuclear power plant is to how to dispose this nuclear waste, because you cannot just throw it outside, right? Because it is harmful for our health, right? So what to do? So let's see, how do we dispose the nuclear waste? So there are two ways. Here you can see the big drums are there, right? Here you can see helium is there, right? Or in this case also waste is there, so nuclear waste is there. So these drums are like this. You cannot just keep this in environment freely like this, right? Because all these are radioactive part. You can also see the symbol here, that is a radioactive, harmful, right? Okay, so how to dispose this? So there are two ways. If you want to dispose that at the near surface, you have to close those nuclear waste in the safe, we can say. Lead, they normally use the lead there. Why lead? Because lead stops the radioactive radiations, we can say, right? It does not allow the radiations to pass. So this safe are made, we can say, made up of metal or lead, something like that. And we have to pack those radio nuclear waste and like that, if you want to keep it near the surface or on the surface, we can say. Or otherwise what you can do, uh, this is a geological repositories, okay? Okay, means you have to dig in the earth, we can say, and put the this nuclear waste inside and seal those things. Once its capacity is over, you have to seal this, obviously, right? This is open retrievable. Retrievable means you can put those more cans there, right? So this is how you can actually dispose the nuclear waste. Okay. So here you can see different countries, which country is producing the most of the nuclear energy, right? Or light. Ultimately, what we all are producing, we are producing the light anyway, right? Okay, electricity. So even we have seen such graph in hydropower plant, right? We said that China was producing most of it. Here you can see USA is at the top, where they are saying 809.4. This is Tera, we can say Tera. Tera means what? Nowadays, you must have heard. We already know the pen drives do come in gigabytes, right? And some hard disks are now there are in terabytes, right? So terabytes means 10 raised to 12. So you can say 809 into 10 raised to 12 kilowatt hour or watt hour, you can say in that case. Okay, this much energy USA is generating from this nuclear power plant, right? If you do remember, in the previous session, we also seen that for hydropower plant, USA was not at the top. It is at the middleware somewhere, right? Because US's main source they are using is the nuclear reactors, nuclear power plants to generate their energy. Then again, France, China, you can see China is again at the top three, right? China obviously have a large population, so the requirement of the electricity is also very large. So they are producing, they are top at, we can say at the almost top at the this nuclear energy also, and hydropower also, right? Right, and we can also see India. India is almost producing 50, let's say 50 terawatt hour in our nuclear power plants. Okay? So in India, Tarapur nuclear power plant is there, which almost produces, let's say 1400 megawatt energy or something, right? So we can produce that much of energy from that, right? So every country has different sources, different power plants. They all have the, let's say, hydropower plant. They also have the nuclear power plant. But let's say some countries which do not have the access to water reservoirs, they will use the nuclear power plant rather than hydropower. Okay, so according to the geography and the resources available, countries chooses their own methods to create the electricity. But ultimately, we know that most of the sources we are using to create the electricity, because yes, electricity is our main requirement of the energy. We know that part. Okay. Good. Chalo, so this is the whole theory part of your chapter. So let's see one or two questions. Which of the following have the chain reaction? Very simple question, right? Nuclear fission. Then the major problem in harnessing nuclear energy is how to, yes, remember this one, disposal of spent fuel safely. We know that is very harmful. Radiations are there, right? Radioactive waste is there. So that is the important. Split nuclei, it's not that difficult. We can easily bombard a neutron. That's easy. Sustain the reaction. Yes, we can even control that reaction. So again, that is easy. Convert nuclear energy into electrical energy. Not difficult. We just have, once we get the heat, then all the other processes are same. We just have to rotate the turbine. Not at all difficult, right? So only the major challenge is to dispose that radioactive materials which are actually harmful, right? Okay. So this is the whole chapter of your energy. Very easy chapter. So you don't have to solve any numericals in that or anything. Theory part is there. And again, it is a lot of a general knowledge type of chapter, right? So just remember the processes, what is happening there. And you can easily write the answers for the questions in the exam, right? So anyway, if you do have any questions on this, so put them in the forum so I can solve the queries. Okay. Good. So we'll stop here. Thank you very much. Have a nice day.